So hey guys, my name is Max, and in this video I'm gonna show you how to install your own Proton Mail like service on your own SMTP server. It's called OpenNeutron. It is my project. I just released it. And yeah, I gotta admit, it's actually my first open source project. I released it just a few days ago, and yeah, I hope you're gonna like it. So it is written in Rust, it's memory and generally safe, and yeah, there's a website called OpenNeutron.com, which is pretty much straightforward, where you can read about this project. So a bunch of things which are really cool about it. First things first is how data is stored. Well, it works exactly the same way like Proton Mail, but actually the thing with Proton Mail is we cannot actually confirm how data is stored, what data is stored. It's basically closed source, right? We do not know on which infrastructure it runs, right? We don't know what software it is running, and generally, yeah. So that's why I decided to make an open source self-hostable version of it on my own. And this describes how data is stored. Basically, at no time does a server store a decryption key or decrypted data by itself. So even if the server gets compromised or gets stolen or whatever, the attacker won't be able to decrypt anything or to read anything. And yeah, the whole process is described here. What hashes are used, what is stored by whom, etc. So basically the backend, long story short, it works like the same way as in Proton Mail, but again, everything is open source and verifiable. Second, I implemented a custom protocol spec. As you can see, it's E2EE, basically an end-to-end encryption protocol. Yes, it really is an extension to an SMTP server, to an SMTP protocol, which does the following. It sees if, as you can see, as you maybe know, in Proton Mail, if you are sending data from Proton Mail to Proton Mail, it's supposed to be end-to-end encrypted. Again, no actual solid way to verify it. And here, if both nodes are, well, running OpenNeutron as their SMTP server, during the handshake, their capabilities are being advertised, and the protocol is described here. And the sender, not even the sender server, but the sender client, gets the public key from the receivers and encrypts the data with the public keys on the client, on the sender client. So it's a true end-to-end encryption protocol implemented here. You can read something more about it, and it just goes on top of the SMTP of a normal SMTP protocol. Well, obviously it has all of the SMTP DKIM verification, it has a TLS, and it's running inside the TLS channel. It is obviously also compatible with legacy SMTP servers, so I tested it with Gmail and with Outlook. It worked seamlessly, it worked with no problems at all. And yeah, so this is a real full working Proton Mail alternative with a true end-to-end encryption if both nodes are supporting it. If not, if there's a legacy, if the sender is legacy, for example, you're receiving an email from Gmail or any other SMTP, well, usual SMTP provider, it's gonna be encrypted with your public key as soon as it hits your server. So again, nothing is readable, the server knows nothing. Well, that comes with a couple of trade-offs, and the most important thing is that losing your password means losing your emails forever. There's no way out of it. If you lost your password, it's unrecoverable. You can read about how public and private keys are derived from your password, just about here, with a salt, with an encryption, with a key derivation, but it's out of the scope. Now I'm just gonna show you how to install it, how to run it. Unfortunately, I don't have a spare server, so I'm gonna just install it locally. And yeah, it is meant for Linux. It was made for Linux in the first place. I haven't tested it on Windows yet, but well, One day I maybe will, but for now it's out of scope. Well, there's this install and setup page here, which describes pretty much straightforward what to do. Let's git clone it over here. So we're just gonna copy it and paste it, and here we go. As you can see, it's pretty fast, and we just have successfully cloned it. Very important, this Rust code does not it's a small self-sustaining binary. It does not rely on OpenSSL or any other dynamically, well, pretty much popular Linux libraries. So yeah, and we're just gonna run and part of build. It builds also, it's actually very fast to build. You can verify it yourself. As you can see, there's a source, utils. That's pretty small, but it works. It's tested. Unfortunately, this is, as you can see, there's Rust code. You can look it up yourself. You can modify it as you will. It's a GPL3 license. You can fork it, whatever, do whatever. And unfortunately, I have to warn you that this project is still in alpha stage, so maybe there are certain edge cases I haven't accounted for. So any help, any feedback would be appreciated. As mentioned, this is my first open source project, and I hope you're gonna like it. I hope you're gonna give it a feedback. So yeah, we've just built it. We can go cargo run, but first let's go through the config, which is pretty much straightforward as well. This is pretty small, so first things first. Domain over here, local.openneutron.com. Normally it should be the same domain as you put into your MX record on DNS. By the way, more to DNS records, well, there's an example configuration to copy here, and these are the DKIM keys for domain verification keys. And how they're generated, it's also just copy paste commands here, and all the DNS records you'd need here. As you can see, all the well, txt, dmarc, a records, whatever, it's pretty much just copy paste here. That's pretty simple, but as mentioned, I don't have a spare server and a spare domain, so unfortunately I won't be able to show it to you, at least in this video. So yeah, then there comes this SMTP port, which is 2525. In my case, I've tested it just with port 25, and with Gmail it works just fine, but there are a lot of SMTP ports. You can choose whatever, and obviously the API port, the port we're going to be accessing the whole thing with, to, well, manage it, to use the web interface. Then we have storage. As you can see, there's this data users, that's where our, well, users and email blobs will be created. Yeah, all the emails and users are stored as flat binary files. Well, that doesn't mean they are decryptable, right? But they just have to be stored somewhere, and I didn't want to rely on any other dependencies, databases, whatever. So I just thought, let's store them as flat files and whatever. Why not? I don't think any single node will be as high loaded so that the IO will be overloaded. I don't think that's gonna trigger an IO overload soon. So maybe one day I'm gonna change it, but for now it's more than enough. Then we have a TLS. Obviously, I would recommend you, if you're running a serious, real SMTP server, I would really recommend you getting a Let's Encrypt TLS key, which is free, I believe, I guess. Yeah, I think it's free. It's free to get, but for now, which is self-signed, which is fine as well. Interestingly enough, self-signed keys also worked with Gmail. It works just fine, so it wasn't a big deal at all. Then we have this DKIM setting, which is a bit confusing, but if it is set to enabled, well, it's enabled, right? It's that's also pretty straightforward, right? If it's enabled, then all emails can come through, even DKIM. No DKIM verification, we don't actually care about them. Well, all non-DKIM emails are marked as unsecure, but they can slip through. You can just disabling it will only leave DKIM verified emails coming in. Well, that might fit your use case, I don't know. I just leave it enabled, so I just want all email, just want to accept all emails. There's this private key. You can generate the private keys. Again, it's described here how you generate the private key. It's just commented out for now. Then the logging is pretty much, well, it's obvious as well. It's in trace mode, so we even see how the TLS handshake is going on. It's for real verbose debug, right? But for normal usage, logging info in info level would be as good. So the trace log mode is more of it for development. I just left it out here. And the last but not least, the GWT tokens. Obviously we have to log into the web interface, authorize, authenticate ourselves, right? And you can set your own, well, secret here. For now it's just commented out, so it's gonna be random on each run, which I personally would recommend you. So after the server restarts, you would be, well, you would be logged out of all the accounts, and you'd have to log in again. I think that's a benefit, but if you don't want that, you can just set your JWT secret and that's gonna work just fine. So this is actually it. There isn't anything much to it. We can cargo run it, and it, as you can see, it starts pretty much instant. It's boot ups pretty fast. So we see two warnings here. One is that no secret was set. All right, tokens will be invalidated on restart. Yeah, as mentioned, and that there are no existing user storage. So one user storage was created. It's a flat binary file here as well. So yeah, we're seeing that the server is listening on port 8080 and the SMTP server is at port 2525. So we can just go to the local page, and as you can see, we have a nice and clean login prompt over here. We can log ourselves in. The standard username is admin, and the password is, and here comes the interesting part, the password is whatever. So we can enter anything. We hit enter, and as you can see, now we can set up the account. We can generate our public key, our private key. The salt was generated, so we can just set up something basic, 123. There is no secure password enforcement on this one, but I would actually add this later. And yeah, a strong password is always much better than a weak one. You gotta, well, admit this one. So yeah, as you can see, the RSA keeper was generated, and we are here live and well. So the interface is pretty simple. It's even simpler than Gmail, because we have a lot of constraints here concerning, for example, again, everything is client-sided, so not a lot of functions here, but we have inbox, start, send drafts. We can create groups, for example, work, whatever. So yeah, anything pretty much very simple. Search, since we are admins, we can go to the admin panel, and it's also pretty simple. So we can add a new user, type in, for example, Max, create a new user. Yeah, we don't want him to be an admin, we just click here and just make it a user. Right, we just click it back, and yeah, we can the most we can do to this user is delete him. So yes, this is it. We can log out now, then type in Max, and password is whatever, so it's uninitialized, so any password is going to work. Type in, so let's set up an account again. Let's type in some other password, and the keys are generated again. And as we can see, there's this is our new email address, max@logo.openneutron.com. So yes, this is basically it. There's nothing more to show, except maybe if you are interested, if you're an engineer and if you're really interested in how the protocol works, you can visit GitHub over the link on my website. The link to the OpenNeutron website you're gonna find in the description below. You can read about how it works. You can read about API. This is basically the same documentations, just written up in the INT file here in the Markdown. You can read a bit more about API if you are, for example, writing your own client, which is totally fair. well, you can read here about how it works, what endpoint returns what, well, what body. You can also read a bit more about the key derivation, how key pair is generated, how it's stored, how it's encrypted. It's over here. It's also pretty interesting if you wanna. And last but not least, how the end-to-end encryption protocol works. As mentioned, again, it's really client, it goes really client to client, so it's a true end-to-end encryption. And here is how the email blob formats work, how the final state machine works, which accepts email, how it's being switched to the OpenNeutron end-to-end encryption mode, and what the data structures look like, how the real code snippets from the real code. Yeah, so this is pretty much it, and thank you guys for watching. I hope you're gonna like this project. Again, this is my first project, first open source project, first actually real project I wrote in Rust, so please don't be disappointed. I hope I'm not gonna disappoint you on this one, because it seems like really cool. It's a really cool idea for me, and I'm gonna use it also for my personal use. I'm gonna self-host this email. I actually already am, right? And I really hope for some feedback. I'm pretty new to cryptography, so please guys, give your feedback. And I hope you're gonna like further videos. I hope you like this video. I hope you are gonna leave a comment on it, and maybe, well, visit one or another of my streams. Yeah, I'm streaming sometimes. Even the creation of this project at the beginning, I streamed it on YouTube. And yeah, again, thanks for watching, and I hope to see you one day or another later.